Hello everybody, in this video we are going to see actual concept of differentiation and integration. So your differentiation is something like this, dy by dx. So this is dy means small change in y and this dx means small change in x. So here we are calculating how y changes with respect to x. So this is what your differentiation. Now we will see it as a graphically. Graphically, if we want to see, then if we have curve like this, so for this particular points that lie on the same tangent, they will have same theta, means same angle. So if you have same theta, then slope formula is slope is equal to tan theta. So you will have same slope for this particular points on the curve. So dy by dx is nothing but it is slope only. That is, if you draw right angle triangle like this, so this is your small dy, this is your small y, and this is your dx. This is your small change in x, and this is your small change in y. So while calculating slope, you calculate tan theta. So you have theta here of the tangent. So tan theta is equal to opposite side means dy, and adjacent side means dx. So this is your slope for particular point on the curve. So in this way you could calculate slope for particular points on the curve like this as a dy by dx. So this is what your differentiation. Now we will see what is integration. Integration, if you have saw, so it was like this, and you have some for example dx here, and you could have here function of x. So integration, if we want to see graphically, so graphically we can say it like this. If you have any curve like this, and you have to calculate area under the curve. For example, if you want to calculate area under the curve, means you have to calculate this area. So how will you calculate? You have a formula, area of rectangle, area of triangle, but you don't have formula for this random figure. So how will you calculate? So for that, you will draw small slim rectangles into this curve, under this curve, so that you could calculate area of this area under this curve. These slim rectangles, so how will you find this area of the slim rectangles? So this you have dx, and length of this rectangle will be the y value, means your function of x value, means you will multiply this function of x to dx. And since you are integrating all the rectangles area, so over a particular interval, for example your curve ends here, you have this b interval, and you have here a interval, here you have a point. So you will integrate this from a to b, so you will get this area under the curve. So basically you will think that where this integration is in use. So it is used in, for you have you know that in physics velocity is equal to displacement upon time. So you can say that displacement is equal to velocity into time. So if you draw a graph of a velocity versus the time graph, so if you have curve like this, so if you want to calculate displacement, then you will find area under, you will find area under this curve. Why? Because you know that for that you have to multiply velocity into time. In this case also, if we integrate, then we are doing the same thing. We are multiplying the function value with the this smaller distance dt over a particular interval, for example a to b. So basically this was your integration and differentiation basic concept that will be very helpful for you if you understand it very thoroughly.